or one more, vowel, vowel, consonant. Still, I haven't written them. Between each letter is an and. So consonant and vowel, or vowel and consonant and vowel, etc. So to find the probability that x is 1, there are 3 different ways to find that. So we have to figure out what's the probability of this combination, and this combination. These ors will turn to an addition sign. So we have to add up all 3 of those probabilities. Okay. So let's start with the first one. What's the chance that the first one we pull out is a consonant? Well, that's going to be 21 out of 26. We put it back. What's the chance we pull out a vowel? Well, there are 5 out of 26 vowels. And then the same for the third one, 5 out of 26. Plus the next one. So vowel, consonant, vowel, same process. 5 out of 26 for the first vowel. The consonant is 21 out of 26. And the third vowel, 5 out of 26. Plus the third possibility, 5 out of 26, 5 out of 26, 21 out of 26. So if we compute one of these, you multiply the 3 fractions together, you get 525 out of 17,576. And what you'll find is all 3 of these combinations have the same probability. They use the same proportions, the same fractions. All that changes is their order. But that doesn't matter. The order in which you multiply doesn't change the result. 2 times 4 is the same as 4 times 2. So all of these will be 525 out of 17,576. So what we could also do is say, well, let's find the probability of one of these outcomes, 525 out of 1776. And then we can multiply that by how many different ways could we see this outcome? How many different ways are there to get one consonant? Well, there are 3 of those. So the number of ways times one of the probabilities all works out to be the same. That's the same as doing the long addition here. So in total, what that gives us is 1575 out of 17,576. So that's the probability that x is 1. Okay. So one more to go. And it's the same process as 1. There are going to be multiple ways to see that outcome. We need to figure out what those are and then find the probabilities. So when x is 2, now we're saying we have 2 consonants. So there would be 1 vowel floating around. So we could have consonant, consonant, vowel, or consonant, vowel, consonant, or vowel, consonant, consonant. So just like before, if we can find the probability of one of these, they're all going to be the same. They'll use the same numbers in a different order. So consonant, consonant, vowel, that's 21 out of 26 times 21 out of 26 times 5 out of 26. And we can multiply that by the 3 different ways that we could see 1 vowel and 2 consonants. So when we do that, we'll have 2,205 out of 17,576 times 3. So the probability that one of these combinations occur is 2205. Add them up 3 times or multiply by 3. It's the same process. So that gives you 6,615 over 17,576. There was another way to find the probability that x is 2. If you recall, we had found 0, 1, and 3, and we know that for this to be a valid probability distribution, all of these have to add up to 1. So we can use the complement rule to find the probability that x is 2. So another way to find the probability that x is 2 would have been to do 1 minus 125 plus 1,575 plus 9,261 all over 17,576. So we're adding together all the probabilities we did have and then subtracting all of those from 1. So if you add all of those up, 125 plus 1575 plus 9261, that leaves you with 10,961. So 1 minus 10,961 over 17,576. We can convert this 1 to be 17,576 over 17,576 minus the other fraction. So now they have the same denominator. So all we have to worry about is the numerator. 17,576 minus 10,961. And we get, oops, sorry, can't see it. We get the same answer, 6615 out of 17,576. So the complement rule still works. Now, there is some caution to be realized in using the complement approach. To find this probability using the complement, you have to use the other 3. Well, if any or all of those are wrong, your complement will be wrong. So if you're sure that you found the other ones correctly, then feel free to use the complement rule. It'll give you the right answer. But if any of your other probabilities were wrong, this will be wrong. They'll all add up to 1, that's fine, but you're using the wrong numbers to add up to 1. So be cautious. So there's the probability distribution. We first thought of the different values our random variable could be, and then we found the probability that we would see those values by thinking about what the outcome looks like, and then using what we were given in the problem. We only have 2 outcomes of interest, vowel or consonant. We know how often each occurs, and we use the multiplication rule to find each probability. When we did 1 and 2, we also did the general addition rule. The ors turn to pluses, the ands turn to multiply. Example 3 is pretty similar to this. But there are less fractions. So let's imagine that the percentage of people who are left-handed in the US is 12%. We're going to randomly sample 3 people, and our random variable what we're counting is how many lefties do we have. So in our group of 3 people, how many people are left-handed? So that's our random variable, the big X. We're counting the number of left-handed people in 3 people who are randomly selected. So then we have to think about, well, what could little x be? What values of that random variable could we observe? How many lefties could we see in 3 people? So just like before, we could have none, 1, 2, or 3. So we do the same process. We create the probability distribution, which is just that table. I didn't draw it very well. But this is the big X. These two are little x's. So 0, 1, 2, 3. So now we have to find the probability of each of these outcomes. And it's the same process as before. So when big X is 0, when we have 0 left-handed people, then that means we're going to have a right-handed person, a right-handed person, and a right-handed person. Well, we know that the probability of being left-handed is 12%, or 0.12. So the probability of being right-handed, well, that's just the complement. That's everything else that's not 12%, so it's 88%, or 0.88. So, to find the probability that X is 0, we have 0.88 times 0.88 times 0.88. So we get 0.681472. Like before, it's going to be easier to do the ends, or the beginning and the end of the distribution first. When you get into the middle, that's when you'll have to think about the different combinations. So when big X is 3, that means all 3 people in the sample are left-handed. So left, and left, and left. So similar to when X is 1, we just multiply that probability together 3 times. 0.12 times 0.12 times 0.12. So we get 0.001728. Okay, now the trickier ones. What about when big X is 1? So this means in our 3 people, we want 1 left-handed person. So we could have left, right, right, or right, left, right, or right, right, left. The left-handed person could be picked first, second, or third. Everyone else has to be right-handed. So what's the probability that we get the left, right, right? Well, we're going to have 12% to get the left-handed person, 88 for the right, 88 for the other right. And just like in the previous example, these other combinations will have the same probabilities, just in a different order. So we can multiply this by 3. So 0.12 times 0.88 times 0.88, 0.092928. And we multiply that by 3. Because we have to take this one, plus this one, plus this one, but they're all the same value. So we get 0.278784. So one more to go. Now the probability that X is 2, that we have 2 left-handed people and 1 right-handed person. So we can start with the complement rule, see what we get, and then we'll check it the non-complement way. So to find X is 2, we know that's what's left over in the distribution. So we want to do 1 minus all of the probabilities that we have already. So 0.681472 plus 0.278784 plus 001728. So if we add those up, that gives us 0.961984. So we should get 0.038016. So let's verify that. So if x is 2, what that means is we'll have two left-handed people. So we could have left, left, right, or the right-handed person could come second, or the right-handed person could come first. And again, these are going to all have the same probability. So if we find the probability of one of them, we can multiply that by the number of combinations, which is still 3.